Number 1A asks us to find or use a sum formula to find the sum of all the positive even integers that are less than 200. So that's going all the way up to 198, and we're starting at 2. So 2, 4, 6, all the way through 198. Now, since it's asking for us to find the sum of all the positive even integers, we already know that we have to use a series. Now, which series that is, geometric or arithmetic, we have to find out. Geometric is when you multiply a certain common ratio to get to the next integer. Arithmetic is when you add a common difference to get to the next integer. So right here, it's a difference, a common difference. The common difference is 2. So you add 2 to 2, you get 4. Add 2 to 4, you get 6, and so on and so forth until you reach 198. So this is the formula for the arithmetic series. Sn, right here, is the sum of the certain amount of numbers. N is the number of terms. A1 is the first term. An is the last term. You divide that by 2. So over here we plugged everything in. Your answer is S99 equals 9,900. For number 1b, it's asking us to complete the missing parts to also represent the sum in summation notation. Summation notation is when you use an epsilon and you find this I over here. I is like the first term out of the entire set, and up top here is the number you're going to. So the number you start with and the number you go to. So on the right here, the 2i, that's the formula you have to use in order to solve the entire equation. So I got epsilon I equals 1, 99, all the way through 99 at the top, and 2 times I. This links to number 1a as well, where it's 2, 4, 6, all the way up to 198. So let's test it out. 1 times 2 is 2, plus 2 times 2 is 4, 2 times 3 is 6. You do the same thing, you repeat the same thing all the way until you reach 198. So 2 times 99 is 198. Therefore, you know the whole thing is equal. And if you add all these numbers up together, you know you will get 9,900, as we proved in the last problem. For problem 1c, we want to use the set of numbers given to us in problem 1a. The set of numbers was 2 plus 4 plus 6 all the way through to 198. Now it's asking us to find the 30th term. So if we want to find the 30th term, we're going to have to use this formula right here, which is the arithmetic sequence. You only use a sequence when you're trying to stop on a certain term. You only use the series when you're trying to find a sum of terms, as I said earlier. So you plug everything in. N obviously is the number of terms. A1 is the first term, and D is the common difference. So you plug everything in, and you end up with A30 equals 60.
Okay, so in this problem, I started with each term and I went up to 15 and I times each term by itself. And so what I got is I was using summation notation, and from there is I got 1240.
So for number 2b, it's asking us to use a special formula only for these kinds of summation notation problems. So 2b is asking, use a special formula for the sum of squares of first n positive integers. Calculate the total number of peaches again. So as you saw in 2a, the number of peaches was 1,240. We solved that by using the the summation notation. This time there's a special formula only for these kinds of problems. The special thing about this whole summation notation problem is the I squared over here. There's only a special problem for that. It's called the sum of all squares, the special formula. It goes Sn, which is the sum of the amount of terms. N is the amount of terms. And then 2n is 2 times the amount of terms, and you divide all that by 6. So we plug everything in right here. Then you combine like terms. You have to do what's in the parentheses first. You go down here, divide 7,440 divided by 6, and this is your final answer, which is the same exact answer as you got in number 2a, 1,240 peaches. So as stated in number 3, that on your 19th birthday, you deposit $6,000 in a retirement bank account that awards you or gives you 7% annual interest, which is equal to 0.07. Since it's annual, you add 1 to 0.07. So 1 plus 0.07 is 1.07. Now, we have to find out if this whole problem is geometric or arithmetic. Since you're going to multiply by 1.07 every single year in order to increase the amount of money you have in your account, it is geometric. Now, to find out if it's a series or a sequence, we are trying to stop on an exact term, the 40th term, which is your 40th birthday. So that is why it is a sequence, because we are not trying to sum up all numbers. We are trying to stop on a certain number, which is the 40th term. So in order to find the number of terms, we take your 40th birthday, subtract it by your current birthday, which is your 19th, you get 21. So in 21 years, how much money will you have? The formula for the geometric sequence is AN, which is the amount of years, or how much money you'll have in the amount of years. A1 is the first term, R is the common ratio, and N is the number of terms. And you subtract that by 1. So as stated down here, A21, so which is your 21st in 21 years, how much money you'll have. 6,000, which is the deposit you already made. 1.07, that is your common ratio that you multiply with every single year to increase the amount of money you had. And 21, that is the amount of years from your 19th birthday until you get to the 40th. So as you see here, you plug in everything, multiply everything out, you get in 21 years, on your 40th birthday, you'll get $23,218.11. So problem 3C is asking you how much money have you earned from your 31st to your 32nd year. So first off, we want to know how much money we earned up until our 31st year, and then we'll find out the rest. So 31st year, we use the geometric sequence problem or formula again. You get $12,629.11. We move down here, we have to find out the 32nd year, how much money we earned in the 32nd year. $13,513.15. Now, you could subtract the two, you'll end up with $884.04. But there's also a way to prove that you only earned 1.07 interest on the amount of money you earned from one year to another. This formula right here, AN equals AN minus 1 times 1.07. So AN right here, this would represent your 32nd year or your last year. And AN minus 1, this represents your first year or your 31st year. So you multiply that by 1.07 to see if you can get the same amount on this side as you did on here. So $13,513.15, that's how much money you have in your 32nd birthday. $12,629.11, that's how much money you have on your 31st birthday. You multiply that by 1.07, you get $13,513.15 on both sides. That proves that you did earn 1.07 every single year. It is still currently your 19th birthday. 3A asks how much money you will have on your 40th. 3B is asking how much money you will have on your 65th. So 3B is the same exact problem as 3A, except the fact that this is your 65th birthday, not your 40th. So to find the difference between, or how many years you'll have to wait until you get this amount of money, you do 65 minus 19, you get 46 right here. That is the amount of years that you will have to wait in order to become 65. The amount of money you'll make. So same exact problem. Plug everything in. A65 that's your 65th birthday. 6,000, that's the amount of money you deposited on your 19th birthday. 1.07 is your common ratio. 46, that represents the amount of years you'll have to wait, and minus 1. So this is your answer right here. You plug in everything, multiply everything out. A65, which is your 65th birthday, you will have $126,014.71.
For this problem, we had to find the 100th term. So what I found out was that each term was getting subtracted by 5. So I used this little equation here to find 46, which was the 100th term. Okay, so in this problem, we're finding the 12th term. And what I did is I just took the 3 and I saw it there getting multiplied. And I put that to the 11th power. And from there, I multiplied it and got this. And then when I multiplied that, I got 12,582,912. So in this problem, we had to find the sum of all 150 terms from question 5. So what I did is I used this formula, and I just plugged it into the problem, and I got negative 54,575. So for this problem, you had to find all 20 terms from question 6. So what I did is I used this formula up here, and I plugged everything in. And then once I did that, I got this long number, and I brought it out, and I got that, what I have boxed in.